when we are looking at the expanded form of these equations, conic sections, a lot of times before we start computing the square to try to figure out the values A, B, and C, to put them in their standard forms, any of that stuff, it's just good to know which conic section we're working with right from the beginning of the problem. So I just want to run through and make sure it's clear how we do that. If I look at these two values here, what I notice is that I have both x squared and y squared. They are both positive, both greater than 0, and they have different coefficients. So with these three features, that makes this an ellipse. And we can see how that changes from one to the next. Because if I look at this one and I check out the same two, it's got, one is the same, 3 is the same, but in step 2, it's a little bit different, right? In this one, either the x or the y, but one of them is negative. One of them is less than 0. So this is what tells me that this one is a hyperbola. So those two are very similar. It's just the only difference you're looking for is this one value negative versus both of them being positive. If we look at this next one, this is probably the easiest one to spot. Because here I have y squared, but there is no x squared. So we're going to say only 1 squared variable. If there's only 1 squared variable, then this is going to be a parabola. And then for this last one, I can see that it actually meets all of the requirements for an ellipse. I have both x squared and y squared. They're both greater than 0, but they both have the same coefficients. That's right in front of you there. But anyway, because this is 2 and this is 2, you'll notice as you start completing the square more and more that the effect that these numbers have on the problem is that they change the denominators of the x squared and the y squared portion of the equation. And so since these are both the same, the denominators are going to be the same as well, which means the major and minor axes are going to be the same. And so if you have an ellipse, because it's positive, but the major and minor axes are both the same, then of course what you're creating is not an ellipse at all, but a circle. So that's how you can tell.